record this lesson. So this is my lesson for the solution of a 3D problem for our MYP3 class. And we are going to solve a problem that involves a bell tower. And I'm sure most of you will recognize the picture that I put in this slide. What is it? Let me know in the chat if you recognize it. We were there a couple of years ago. Right? Eleonora, sono contento che mi senti meglio. Yes, Martina Rasetto, exactly. It's the bell tower, the church from Upega. I miss it. I hope I can go back there soon. But anyway, it just inspired me thinking about Upega and the bell tower. It inspired me for this problem. And I am modeling, obviously, a bell tower with two solid shapes, a prism at the base and a pyramid on top, which is the roof. Okay, so let's read the problem together. It says we are supposed to build a bell tower up from a flat surface, which is a square. So the bell tower will be sitting on a square surface, and the square surface is 16.81 square meter wide. And then we are supposed to raise the building to a top of 20 meters, excluding the rooftop. So basically, my prism will have a height of 20 meters. And then we will build a pyramid on top of this. The rooftop is a pyramid with a volume which is 1/8 of the volume of the main body, which is a prism. And I am color coding the text of my problem so that you can also compare it to the little picture that we have on the right. So the purple, violet, kind of pinkish shape is a prism, and it's the body of the bell tower. Well, it's the right part, the vertical one. And then on top of it, we have a rooftop, which is a pyramid, of course. What we need to find is the appropriate height for the rooftop, okay? So that we reach this condition of having 1/8 of the volume. So we cannot hold more than 1/8 of the volume for some reason. Those are some constraints that we have been given, maybe by the architects or the engineers that are working on this project. And so we need to find the height of the pyramid. We know the height of the main body. We know it's 20 meters, but we need to build the pyramid on top of it with an appropriate, suitable height. Okay, so I have written my data. And I would like you to learn from my slides how to write appropriate data that is meaningful. Now, we don't know whether you're gonna have your Terza Media exam yet, what's gonna happen in the next months, but let's pretend you're gonna take the exam. Maybe you will not take it in June, maybe later. I have no idea what's gonna happen, guys. But I'm hopeful that something will happen. Eleonora, you wanna say something?
Mister, but the base, it's a square.
It's a square, yes. If you read the text, it says that the base has a flat surface of 16.81 and it's a square, okay? So from my picture, it looks like a parallelogram, of course, because it's done in axonometry, but it's a square.
Yeah.
Okay, thank you.
Thanks.
Thank you for your question. Thank you for clarifying. It's written clearly and underlined. I know I was gonna get this question, but let me put some highlight on it. Okay, it's a square base. Let's look at the data one by one. We have the surface of the base, and it says it's a square, okay? So, and I can write the fact that it's a square by saying that the segment AB, the segment BC, the segment DC, and the segment AD, they all have the same length. It's a square. Plus the height of our prism, the height of the purple body of the bell tower is 20 meters. And the height can be identified, for example, with the segment CF, okay? The one that I see here, CF, I don't know if you see my little cursor moving, the rightmost edge of my bell tower, but also EB or AH or any of the other of the vertical edges, segments that constitute the prism. It's 20 meters. Furthermore, we also know that the volume of the pyramid, and look at how I wrote it. I could have written volume of the pyramid, but I also wrote V HEGFO. HEGFO is nothing but the name of this pyramid, if you want. So let me highlight it. Maybe if I have an orange, no, there's no orange. Well, I'll try to highlight it in yellow. Okay, so HEGFO are the vertices of my pyramid. H, G, E, F, and O are the 5 vertices of my pyramid, and that's what I'm using as a name for the pyramid. While for the prism, I'm using the name A, B, C, D, E, F, G, H, because those are the 8 vertices that constitute my prism. That's a unique way to identify a prism or an object that we are talking about. And I recommend that you use this notation or some sort of notation to distinguish between different volumes, because this is not a problem where we just have to calculate one volume or we're talking about one shape. We are talking about different shapes with different volumes. So it is really important for me, for you actually, it is really important that you practice using good notation to point the attention of the reader to what you're talking about. I'm talking about the pyramid, so I will write volume of the pyramid, V pyramid. I'm talking about the prism, so I will write V prism, okay? The volume of my prism. Let's color code this one as well with a different color. I'm trying to, okay, let's color code it in red. Let's color code this other one in red. And I'm sorry if I'm going too slow maybe, but I really want you to understand how important this phase of the problem is. Giorgio, sì.
Ce lo metterà su Management?
Questa poi è tutto su Management, certamente. Yes, everything will be, okay. Don't worry. So I will share everything with you. Okay. So let's try to work on the solution. What I need to find, and I will just work on the first question. I want to find the height of the pyramid, which is OT. Okay. So OT, the distance between the vertex of the pyramid and the base of the pyramid, which happens to also be the base of the prism. That's what I need to find. Okay, so solution. What can we do as a first step? Well, I think the first thing that we can find, for example, is how to, I think we should find the volume of the prism we have already, but I think we should find the volume of our pyramid, because we know that it's 1/8 of the volume of the prism. However, if I look at my data, there is no volume of the prism anyway. So I think the first thing to calculate is the volume of the prism. So I am going to find the volume of the prism, and I don't know why it's underlining, but I will take this away immediately. So the volume of the prism is equal, if we look at the formula that we had before, as the area of the base of the prism, which I call ABCD, right? If you look at our shape here, ABCD is the base of the prism times the height of the prism, which is, for example, CF. Actually, let me write height for the moment. Okay, I really want to stress the focus right now. I really want you to notice how I'm writing down my solution. The first thing I do, I don't do any calculation at the moment. I just write down what I want to calculate first. What I want to calculate is the volume of the prism. What I use is then the formula, okay, which is the area of the baseline height. Armando, you have a question?
No, I wanted to say what you said about the prism. I wanted to say what we had to do to find the volume.
Ah, okay, fantastic. Yeah. Well, thank you. We have the formula, okay, Armando. So the formula is here. And now I will populate the formula, okay? Instead of H, actually, I think it's better to write CF. It's more appropriate because H doesn't mean anything in this case. And then I substitute the numbers that I have into this formula, which is area of the base, 16.81 meters, times the height, which is 20 meters. Okay, and then I can do the calculation. My calculator has done it for me already. It should be 336.2. And what, raise your hand if you know what you need to put here. What kind of unit do we put now? 336.2 what? Maybe you're writing in the chat. Meter cubed. Yeah, because, yeah, I made a mistake before. It's not 16.81 meters, but it's meter squared. So meter squared times meter will give me meters cubed. And in fact, it's a volume. Let me see what you guys are saying in the chat. Meter cubed, exactly. Meters cubed. I call this method here WHS. Let me insert a little funny shape here. Let me see if I can choose one that I kind of like. Yeah, I kind of like this one. Let me see. I call it, oops, WHS, and I just want to make it W, oops. Oh. W, yes, HS. What does it mean? It means, well, I will write it. Oh, let me see if I can put it a little bigger. Okay, WHS means to me what, how, and then solve, or substitute actually. What, how, and substitute. So I'm writing what I'm going to calculate. What? The volume of the prism. I'm writing how I'm going to calculate it using the formula. So writing down the formula, it's important that you write it down. And you write it down using the names of your problem. You just don't write down area of the base time height. You don't write down the general formula that you have in my slides, one page before this one, or 2 pages before this one. You write the formula where you show clearly the names of your shape, the name of your problem, the ones that we are using now. So area of ABCD times CF, which is the height. And now S, substitute. Okay, so what, how, and substitution. The substitution is the phase where you actually do the calculation, but before you do the calculation, you just write it down what you're calculating. So you see how it is important to go slow and do it step by step. Now we've calculated the volume. Great. What other thing can we calculate now? Anybody? I don't know why this is going. Go. Let me see if I can put it to the right. Another thing that we can calculate, share with me in the chat. What is your suggestion for calculation now? What do we need? Now we have the volume of the prism. What can we calculate now? Remember, we need to go to the height of the, what's it called? The height of the pyramid. This is what we need to calculate. Yeah, Jeremy says the volume of the pyramid. That's exactly what we're gonna find. And to calculate the volume of the pyramid, again, using this technique of WHS, I'm gonna write what I'm calculating, the volume of the pyramid. Look at how I did the whole index thing. I don't know if you noticed, if you wanna use Word, but if you wanna put something like at the bottom, you put underscore, you write whatever it is, so pyramid without stopping, and then when you hit on space, it will automatically give you the little index notation, okay? The volume of the pyramid by the data of our problem is 1/8, and look at how nice it is to do fractions. You just do 1 divided by 8, and when you hit the space, it will just automatically give you a nice fraction. C dot is the command that I use for the multiplication. It's a central dot, C dot. So it's, let me show you again, slash C dot. and then when you hit the space, it will write the dot. 1/8 of the volume of my prism. So this is how I'm going to calculate the volume of the pyramid. So I've written what, I've written how, and now I substitute. Well, it's just 1 divided by 8 times the volume of the prism that we just found now. And remember to put the units, it's important. And this is something I've just calculated already. It's 42.025, again, cubic meters. Okay, so this is the volume of my pyramid. We found it. Any suggestion now, but I would like to hear from somebody instead of just writing in the chat. But if you could just raise your hand, if you know how to proceed in order to find the height. Jeremy, I'll let you speak. Go ahead. Vai, Jeremy. Non volevi più parlare? Avevi alzato la mano.
Il volume della piramide, quindi 36.2 più 42.025.
Ti sto sentendo malissimo, non so se sia un problema del tuo volume o del mio, ho alzato al massimo, ma ti ho sentito veramente male. Mi dispiace, Jeremy, mi sembrava che tu avessi detto una cosa che andava bene. Provo a sentire un attimo Armando. Vai, Armando.
Vogliamo trovare ora l'altezza della piramide.
Chiaro, e come facciamo?
Bisogna fare volume della piramide per 3 diviso l'area del quadrato
Della base della piramide, perché c'è la formula inversa, esattamente. Allora, se sapete una formula inversa, if you know the inverse formula like Armando does, that's perfect. But I will show you how to do it using an equation because I'm not particularly good at inverse formula, or let's say I don't remember the inverse formula. What I'm going to do is that I will just write the formula for the volume of a pyramid. Okay, the volume of a pyramid. Thank you, Armando. I will mute you now. So volume of the pyramid, which by the way, I have just calculated. Well, the formula for the volume of the pyramid is the area of the base. So again, ABCD or whatever the other base is, ABCD, EFGH. EFGH should be the base of the pyramid times, the height of the pyramid, which is OT, if I remember well, divided by, let's see if I can have a look at the picture again. Looks like I'm writing things right. Yes, OT is the height of the pyramid, and EFGH or whatever is the base of the pyramid. Let me put this in the center, okay? So that I also make it a little bigger. This is my main formula for the volume of the pyramid. Let's look at this formula. Do I know the volume of the pyramid? Yes. Do I know the area of the base? Yes. Do I know this one, OT, the height? No, it's what I need to find. Well, that means I have everything in this formula except for one missing piece, OT, the height, which means I can solve it easily using an equation. I can put as x OT. So now I can find, I don't know why it's giving me this, but I would like to, okay? I would like to find the x that is missing. Emilio. Emilio, ti sento, vai. It's your time. It's your turn.
Ho alzato la mano? Ah no, per sbaglio, scusi.
Well, I will just keep going. So I substitute into my formula all the information. So substitution into the formula. Here it is. The volume of the pyramid, I just calculated it. It's 42.025. And that should be equal to, let's see, the area of the base, which is 16.81, times times the height that I need to find, which is x, divided by 3. There we go. This is what I just have substituted into my formula. So the volume of the pyramid, again, volume of the pyramid, 42.025. And the area of the base, 16.81. And then OT is X. I am missing a few things, which is the actual, sorry, I need to sneeze, but I can't. Anyway, I'm missing the units. Let me add them now. 16.81 meter cubed times X divided by 3. What do I do now? Well, you know what? I'm just going to copy this one and go to the next page to see if we can solve it decently, because now we just need to find X. Well, just need to find X, as if it was easy. Any suggestion in the chat on how to proceed and solve this? You were trying to delete that, ignore it, that's okay. Okay, times 3, that's a good suggestion, Emilio Pedemonte. X alone and the rest is the solution, Pietro Andrei, I agree, but before we actually get to the point that X is alone, we need to do a few things. My first suggestion would be definitely multiply by 3, both sides, like we did last time when we were solving equations. So let's take this one, multiply by 3, both sides, okay, 3 times, and 3 times also to the other side. C dot 3, so everything will just disappear. And what we get is basically, I don't know what's going on, but there we go. 3 times 42.025. If I'm not mistaken, it's 126.075. Okay, on the one hand, and it's meters cubed. I don't know, something happened with the language of my keyboard. So meters cubed, and that would be equal to, well, we're left on the other side because the 3 disappears from the denominator. It's just 16.81 meters squared times X. Okay. Okay, so we're almost there with the equation. I think I will write it in a better way, which is simply changing the order of the 2 sides of the equation. So here we go. I'm just gonna swap the equation and switch it left to right. Armando, your hand is still raising. I don't know if you wanna ask something. I'll let you speak.
No, ho sbagliato.
No problem, no problem. We'll keep going. Any suggestion in the chat on what to do now? Yes, somebody has found the solution already, which is 7.5. That's correct, because what I need to do now is simply to divide by 16.81 cubic meters. And so this is what I get. X is equal to, parenthesis, 16.81, sorry, it's the opposite, 126.075 cubic meters divided by 16.81 square meters. Okay, and if you do the calculation and also the simplification of the meters, let me see if I can draw something for you guys. Apparently not. Let me try to do it now. I just want to simplify the 3 here with the cubic meters all together. I'm left with meters, by the way, obviously, because it's going to be a length. So what do we get? We get a result of 7.5 meters by using the calculator. Okay, and we have reached the solution to the first part of the problem. So answer to the first part is that the height of the pyramid is 7.5 meters. I'll stop here, guys. I'll let you work as a homework on the calculation of the lateral surface of the whole bell tower, which is the lateral surface of the prism plus the lateral surface of the pyramid. But I want to point out today, I think the main point of my lesson was this WHS thing. In order to show clearly your line of reasoning, I want you to first write what you're about to calculate, then tell me how you're calculating it, and then substituting the numbers inside. Okay, and then you will do a calculation. I think way too many people, from my experience as a teacher, when they have to solve problems, way too many people focus on this part here, like the writing down numbers and calculations, which make no sense, especially if we are trying to make some sense of the whole problem. It's easy to get lost, okay, even for you, let alone for the teacher or the person that is trying to correct what you're writing. So be explicit in this first phase with the W and with the H. What are you calculating? How are you calculating? I'll let you work as a homework and then as a project if you want. I will be more than happy to correct. I will give you an assignment on ManageBack that is not mandatory, but if you want, you can definitely work on this little project and model the other nice piece of architecture that we have in Upera, which is the Church Madonna della Neve, the Lady of the Snow. And you can model it using prisms. And then you can invent. How do you do the multiplication point? Ask me, Matteo Preve. Let me show you again, Matteo, that if I go back to any formula, okay, and the formula is reached by inserting a formula, inserting an equation, okay, or if you want, on Windows, I also use the shortcut Shift-Alt equals, okay, it will just open a little equation box for you, which I can bring to the left-hand side, for example. But if I want to write 35 times 71, for example, well, I can do /times, but it will give me the regular times as a cross, which is not a good idea. I don't like this symbol. It reminds me of an X. So I do C dot, central dot will give you the little dot for the multiplication. Okay. And there are many other tricks that I can teach you maybe another day about writing and typing on Microsoft Word using the editor. If you have any other question, please. Okay, Sofia Gallegari, that's definitely too much of a too big of a number, 335180. I don't know where you got it. That's too much. That's too high. Okay, definitely we don't want a bell tower with that height. If you have any question, raise your hand. It's time for you to do it. I will just stop sharing my document, but don't worry, you will have it on ManageBack. Let's go back to the regular interaction here. Raise your hand if you have any question about what I've done today. Otherwise, I will just stop recording. So this is